Welcome back to this explainer of the PFVME Research Journal. If you're into the wild intersections of neuroscience, AI, and robotics, you are absolutely in the right place. We're diving right into the second installment of this ongoing journal, and today we're tackling a massive question. Is it actually possible to create primitive intelligence just by layering simple systems together until complexity naturally emerges? To figure that out, we literally have to look at failure, specifically why the first two versions of this incredibly ambitious project completely fell apart the moment they hit the real world.
So, here's our roadmap for today. We'll look at a completely different kind of AI, how complexity grows from layered simplicity, what happens when you introduce the noise of reality, exactly why version 2 failed, and finally, the biological redesign it inspired.
Section 1. A different kind of AI, rejecting the mainstream.
Most of the AI we hear about today starts with a massive advantage that biological creatures just don't have. Mainstream AI absorbs billions of human-labeled examples, relies heavily on our language, and runs on these mind-bogglingly expensive server clusters. Basically, it begins life already viewing the world through human definitions. But PFVME, it went completely rogue. The creator started with literally one consumer surveillance camera, a couple of secondhand PCs, and absolutely zero pre-programmed knowledge. No one told this system what a bird, or a tree, or even grass was. It was forced to learn entirely through continuous observation, starting from a total blank slate. Just like a real living creature.
Section 2. Complexity from layered simplicity. This is the core philosophy of the whole project.
So to build an AI from this true blank slate, the developer laid down some unshakable rules. The goal here wasn't to brute force a human mind or, get a computer to write poetry. Trying to jump straight to human-level intelligence? That's like trying to build a skyscraper before you even know how to pour concrete. Instead, the focus was entirely on emergent complexity. The rules were strict: no human labels, no language, and absolutely no human assumptions. The system just watches pixels change, looking for persistence and relationships. If complex concepts were going to emerge, they had to come strictly from the AI's own layered, first-hand experience.
They were heavily guided by this Richard Feynman quote, "Take what little you know, test it against reality, and build from there." Guided by that philosophy, the creator treated every single version of this software as a raw, real-world experiment. You don't try to design the perfect brain on paper. You build a simple layer, you throw it out into the absolute chaos of reality, you watch it inevitably break, and then you ask, well, why?
Section 3. The noise of reality. Or, as I like to think of it, when the garden fights back.
Think about it. Movement attracts attention in almost all biological animals, right? Whether you're a bird, a cat, or a human. So version 1's very first goal was simply to track moving objects. But nature is wonderfully inconvenient. A real garden is just so incredibly visually noisy. You've got leaves fluttering in the wind, long shadows drifting across the lawn over hours, clouds changing the brightness of the whole scene in a matter of seconds. And because this primitive AI treated all visual change as equally important movement, it almost immediately hit a system overload. It was completely overwhelmed by the sheer noise of reality.
To fix this, they introduced something called a stability map. Instead of constantly asking what just moved, the system first spent time learning what normally stays exactly the same. It essentially mapped the stable background. And this was a huge breakthrough. It brilliantly allowed the system to ignore all that environmental noise like swaying branches and focus only on genuine, independent deviations. The magical moment was when the system successfully tracked a flock of about 15 to 20 individual birds taking flight, actually keeping separate tracks for each one without mushing them all into one giant confused moving blob.
But here's the catch. Dealing with real-world continuous observation takes serious processing power. And this brings up a really cool parallel. Think back to developers in the 1970s who had mere megabytes to work with. The strict, self-imposed hardware limits of this project, using older, secondhand desktops, forced that exact same mindset. Today we're so used to solving software problems just by throwing more gigabytes at them. But here, continuous camera observation generates an insane amount of data. It forced really elegant engineering and brutal decisions. What do we keep in active memory? What do we compress? What do we just forget? It completely punished lazy design.
Section 4. Why version 2 failed. Let's look at the fatal flaw.
So despite mastering that stability map and getting really efficient with data, versions 1 and 2 hit a massive wall that meant they absolutely had to fail. On paper, the original architecture seemed perfectly logical. A three-part pipeline. You had the perception machine watching the world, the brain analyzing the important events, and the server acting as long-term storage. The idea was that the perception machine would observe the environment,
decide what was important, and pass that data up to the brain. It sounds like totally standard, solid software engineering, right? But when they tested it continuously against the relentless data of reality, a fatal architectural flaw revealed itself. The system started fighting against itself. So what was the fundamental mistake hidden in this logical pipeline?
The eyes were deciding what the brain should think about.
Yeah, the flaw was entirely about responsibility. The perception system was effectively making cognitive decisions. It was pre-filtering reality, deciding what mattered and where to look before the brain had even seen the raw data. Biologically speaking, that is incredibly unnatural. I mean, eyes don't think, they just observe. By having the perception machine decide what was important enough to pass along, the architecture was giving the eyes a job they should never, ever perform. Only the brain has the context to determine what actually deserves attention. Patching the code wouldn't fix this. The entire structural philosophy was backward.
Section 5. The biological redesign. Failing forward.
Rather than stubbornly trying to patch up a flawed architecture, the developer brought in AI collaborators, specifically ChatGPT and Codex, to just rapidly tear it all down. This didn't replace the developer's vision, but it dramatically sped up the feedback loop. It made it so much easier to toss out bad ideas without getting overly attached to them. The resulting version 3 wasn't a tweak, it was a complete biological redesign. They threw out the traditional software pipeline and replaced it with a beautifully layered cognitive system inspired directly by neuroscience.
The first major shift was introducing the conscious machine. This layer took over immediate perception, active attention, and survival-oriented decision-making. And here's the crucial part. It receives the raw camera feed directly, zero pre-filtering from any lower-level program. It acts just like the active, focused part of a brain, deciding in real time what actually matters right now.
Meanwhile, because the conscious machine is now handling the chaotic immediate reality, the new subconscious machine was freed up to do what it does best. It handles all the slower processing. Working in the background, it discovers complex patterns, consolidates memories onto the long-term server, and literally replays experiences to learn from them. It's almost exactly like what an animal does when it sleeps. It's this incredibly elegant division of labor modeled straight from biological cognition.
By building that initial system, watching it utterly fail in a messy garden, and realizing the eyes were trying to do the thinking, the creator learned a massive lesson. Intelligent behavior depends just as much on where decisions are made in an architecture as how they are made. In a layered cognitive system, structural placement isn't just some neat optimization trick. It's the absolute foundation for emergent complexity.
So as version 4 of the PFVME project now quietly watches the world through its single camera, learning continually, storing memories, and processing everything through these conscious and subconscious layers, we are left with a huge question. If we stop trying to just program intelligence directly, and instead build an architecture that mimics the layered observational simplicity of nature, will genuine, unprompted machine intelligence finally begin to emerge? It's a thrilling thought to leave you with. Thanks for joining me on this explainer, and keep questioning the layers of the world around you.